Hello all. Today we are going to solve insertion sort in Geeks for Geeks. In insertion sort, concept and logic that is used is initially we'll take the element that is present in the first index as the key element, and the element that is present in the zeroth index is always considered as it is placed in its correct position as if it is sorted. So this is the main thing that we're going to do in this. So since the zeroth element is already in its correct position, we're going to take the element in the first index. Okay va? So once we take the element in the first index, we are going to compare this element with the element present in the zeroth index. If the element present in the zeroth index is greater than the element present in the first index, we'll simply swap it. The same way we're going to do this for the entire array. In the second iteration, what we'll be doing is we'll be taking the key as the element present in the second index, that is logically the third element present in the array, and we will be checking this third element with all the elements that are present previously, that are present before this element, which means we'll be comparing the element present in the third position with the elements present in the first position and second position. Actually, the order will be like we'll first compare the element present in the third position with the second element, and then again that will be compared with the first element, and all the three elements will be correctly placed in their respective positions. This is just like arranging the cards that we play, right? So we'll be taking each card and we'll be putting them in the correct position. So this is done in the insertion sort. Okay, now let's implement this logic in Java. So this is what is given in this examples also. So here we could see that the arrays are sorted. So let us implement the insertion sort here. Okay, we are given with an array. As we have already told, we are going to take the element present in the first index as the key. So we have to start from, for int I is equal to 1. We have to start from 1, and I should be less than the length of the array. Let us declare the length of the array as n. So n is equal to array dot length. Okay, and for int I is equal to 1, I less than n, I plus plus. Now I'm going to initialize a variable key which is not, which will hold the value of array of I. So initially consider the element present in the first index, which means array of 1 will be the key, and j will be I minus 1, which is nothing but 0. So this will point to the 0th index. Okay, now let me write a while loop. While this j value is greater than or equal to 0, and when should I perform a swap? If this j, which means if the array of j is greater than the key is nothing but array of I. If 0th index element is greater than the element of the first index, then we will swap them, right? That is what the condition given here. So if j is greater than or equal to 0 and array of j is greater than key, then array of j plus 1, which is nothing but the actual element that is holding the key value. That is what array of j plus 1. Then the array of j plus 1 will simply hold the value of array of j and will decrement j. When this particular while loop condition fails, we can assign array of j plus 1 is equal to key. I'll explain this condition. See, in the first iteration, let me take a case like this, okay? Like 10, 9, or else let us take this example. In the first iteration, this 4 is nothing but j. So j is nothing but I minus 1. And what is array of I is 1. 1 is array of I and 1 is the key value. 1 is the key in the first iteration. Okay, so 1 is key and 4 is nothing but j. Now we are entering into the while loop. What is j? J is I minus 1. I is 1. So j is equal to 0. So 0 is greater than or equal to 0. Yes. So I'm giving this for the array 4 comma 1 initially. Okay, wow. They are not correctly placed. Okay. So now j is actually 0 and array of j is nothing but 4. 4 is greater than the key. Yes, 4 is greater than 1. Now what we'll do is array of j plus 1. What is array of j? J is nothing but 0, right? Array of j plus 1 is nothing but this particular value, that is 1. So array of j is 4. Array of j plus 1 is 1. So this array of j plus 1 will hold the value of array of j. So this 1 becomes 4. Once we update this, we're going to decrement j, and now j will become, already j is 0, so j will become minus 1 because j minus minus, so 0 minus 1 is minus 1. So again we're going to check whether this condition satisfies. Here j should be greater than or equal to 0, but in our case j is equal to minus 1. Hence this condition, this loop fails to execute. Hence we go to this, we come to this particular uh, line. So array of j plus 1 is nothing but array of, already j is minus 1. So minus 1 plus 1 will become 0. So array of j, which is nothing but this particular element, will store the value of key. Already I had key is equal to array of I, that is nothing but the element that we stored here, that is 1. So this will become 1. So at the end of the first iteration, we could see that the array will be of 1 and 4 at the end of the first iteration. So this is how the entire array is sorted. Okay, I hope you understand. And now let's just compile this. Yeah, compilation completed. We get a compilation error like, oh sorry, int. This is int j. We haven't in. Okay. Yeah, compilation completed successfully. Now let's submit this. Yeah, problem solved successfully. So this is how we implement insertion sorting algorithm. Thank you.